All right, so it is what day is it? Day 11, and it is Thursday, June 12th in geometry. So I'm going to go ahead and title this Geometry. And we are beginning Unit 3. So I'm going to write real big here, Unit 3. Okay, and it is Thursday, June 12th, page 1, and these are our day 11 notes. Okay, and what I just showed you here is a shape that has 4 sides and 4 angles. Okay, this is, we're going to write this word down, a quadrilateral. Q-U-A-D. Quadrilateral. Okay, everybody say quadrilateral. Quadrilateral. Beautiful. A quadrilateral is a shape with 4 sides and 4 angles. Okay, so we're going to put that here. 4 sides. 4 angles. Oh, you're okay. And what did we find out that those 4 angles add up to? 360 degrees. Yes.
Quadrilaterals include shapes that have 1 curve.
That include one what?
1 corner inverted.
1 corner inverted. As long as there are still 4 sides and 4 angles, then yes. Yes. So Erica asked, would a quadrilateral still include a shape, for example, where one of our corners is inverted like this? 1, 2, 3. Oops.
No.
Wait a minute. Hang on. 1, 2, 3, 4. Like that. This is a quadrilateral. It has 4 sides. 1, 2, 3, 4. It has 4 angles. 1, 2, 3, 4. That 4th one's just really big. Any shape with 4 sides and 4 angles is a quadrilateral. It doesn't necessarily have to look like a square or a rectangle or anything like that. But we do know that no matter what, these 4 angles, because when we put them all together like this, we see they complete one full 360 degree rotation. They add up to 360 degrees. And that is important. Now, under quadrilaterals, any shape with 4 sides and 4 angles, there are more specific categories that we can talk about. And the first one I'm going to tell you about is called a parallelogram. A parallelogram. I'm going to write that word down too. Let me grab a color. So, parallelogram. Okay. Parallelogram. Now you guys say it. Ready? Parallelogram. Parallelogram. Good. A parallelogram is a quadrilateral. It always has 4 sides and 4 angles, But now we're adding another sort of specific detail about it, and that is that the sides are parallel to each other. Now, who remembers what it means to be parallel? Lines that never cross. That means they're going to be kind of going at the exact same angle. So I'm going to show you an example of a parallelogram. For example, we could have, here is a side, here is another side. These sides are going at the same angle. We would say that they are parallel, and we might see these little arrows on them. And then you would have two other opposite sides, and these are parallel. Now, this is not a rectangle technically, because rectangles are even more specific. This is a parallelogram. The sides that are opposite are parallel to each other. Okay, so that's a parallelogram. Now, if we want to get more specific, the next step is a rectangle, actually. So this is a parallelogram. Parallelograms also have another unique feature. It's that the angles across from each other are equal. So I'm going to mark that here. This big angle is equal to that big angle. So I'm going to write opposite sides. Sorry, I stuck a word in before, so if that messed your notes up, I do apologize. Opposite sides are parallel, and opposite angles are equal. Okay. So, a parallelogram has opposite sides parallel, opposite angles equal, and a parallelogram is also considered a quadrilateral because not only does it have these specific qualities, but it also must have the four sides and the four angles. So, every shape I tell you about today is a quadrilateral. They will all have four sides and four angles. But as we go, we're just going to get more and more specific, okay? Yes?
Would you consider a bow tie quadrilateral?
A bow tie. Like an untied bow tie?
Like two triangles that are facing.
Two triangles facing each other. Like, let me see if I can draw. One like this. So let's see, we'd have one side. Technically, I guess if you count that as a side and that as a side, 1, 2, 3, 4. I'm going to say this is not a quadrilateral because now you have 1, 2, 3, 4, 5, 6 angles. And I think once those lines cross each other, we would consider these as separate sides. So I'm going to say no, this is not a quadrilateral. But that's a good question. Good question. Okay, yes?
Did you say opposite sides add up?
Opposite sides, they don't add up, they're equal.
Okay.
Equal. Okay. So, the next more specific we can get would be a rectangle. Rectangle. Now a rectangle is a parallelogram, believe it or not. A rectangle has opposite sides that are parallel and opposite angles are equal, but now we're adding a, let's see, we're adding another, I can't ever think of the word I'm trying to think of, another specification. In a rectangle, all angles are 90 degrees. So you will have all angles 90 degrees. And an example of a rectangle, I'll draw one. Rectangles have all of these features. There will be 4 sides, 4 angles. The opposite sides will be parallel and equal, and the opposite angles are equal because they're all 90. So here is an example of a rectangle, and it's not perfect. So if I want to show that this is a rectangle, what should I put in the corners of my shape? My little boxes, my squares, to show that it's 90 degrees. This is a rectangle. Our sides that are opposite are also parallel. They're equal to each other. So we could also put some of these little tick marks to show that they are equal. Okay. And I suppose you could also put the little arrows if you want, but you know, there comes a point when we're being a little bit overkill. So there's your rectangle. And we have one more I'm going to introduce today that I'm sure you all have seen and heard before. Slightly more specific than a rectangle. A rhombus is a quadrilateral. I'm not showing you that today though, just because a rhombus is on a little strand of its own. It's a special, very special quadrilateral. Believe it or not, the next more specific we can get is a square. So, square. That's the next one. Now, what do you think, if anybody knows, what do you think is going to be the difference between a rectangle and a square? Yes?
All the sides are equal.
All the sides are equal. That is the only new change. In a square, you still have 4 sides and 4 angles that add up to 360. In a square, your opposite sides are still parallel. Your opposite angles are equal. All the angles are 90 degrees, but now all the sides are also equal. They're all the same length. All 4 sides are equal. Same length. So, an example of a square would be, I'm going to try to draw it as equal as I can, like that. Sorry, it's not perfect. We'll show our 90 degrees at each angle. And since all 4 sides are equal, we put just 1 tick mark on every side to show that they are all the same. Okay. So, that's what we are introducing today as far as the shapes go. And I'll give everybody a minute to make sure that you've got that in your notes. And then we're going to go to the next page and we're going to start learning some things about these shapes and how we can solve stuff with them. Yes? What follows all the same rules?
The bow tie.
The bow tie.
Ignore the intersection.
If you ignore the intersection. Technically it would, but sadly we can't ignore the intersection. It does exist. But that's interesting. I might have to, you always give me things to think about. I love it. I'm going to look it up later and see what I can find on it. Bow tie versus quadrilateral. Yeah, after this lesson, I'm going to do some digging, see what I can find. Okay, so these are the quadrilaterals I'm showing you today for now. And with these quadrilaterals, I'm going to go to the next page. And we're going to learn 2 new words. So I'm going to title this again, Geometry Unit 3 again. But now we're on page 2. And day 11 notes continued. So the next thing we're going to write in our notes is area versus perimeter. Area versus perimeter. Does anybody know what area or perimeter is? Erica?
The area is the area inside the shape. It's the space inside the shape.
Yes.
The perimeter is the line around it.
Yes. I mean, that's the perfect way to describe it. The area describes all the space that the shape takes up, all the space inside the shape. That's the area. And I'll write this down. The perimeter is measuring the length of all the lines added together around the shape. So we're going to draw a picture to help us remember this and a definition. So area, let's do a picture first. Let's see. I am going to actually use my ruler. And I will do, I'm going to do sort of a parallelogram for this example. So I'm going to draw that. Just like this. And it doesn't have to be perfect. You can do this with any other shape, really. So area, I'll use green, and perimeter, I'll use light blue. Okay. So the area of a shape, just like we said, is the space inside of the shape. That is area. It's the space inside of a shape. And I'm going to color it. Okay. Perimeter is going to be all of the side lengths. Like if I were to take this line, this line, this line, and this line, and put them all together and line them up, whatever that length is the perimeter. So I'm going to outline the whole shape. I'm going to write perimeter. I'm going to write that on all four sides. Okay. And we will define perimeter as the total, basically the total distance around the shape, around the outside of the shape. Outside of a shape. Okay. And there are a few formulas that we will learn for finding perimeter and area, and it's going to make our lives a lot easier just knowing, well, here's my formula, and you can just plug numbers in and solve for things. So I'm going to give us a few examples of how we can use area and perimeter. So an example might be, let's see, let's start with a parallelogram again, and I'm going to give you a few measurements. On your parallelogram, you're going to have a side length, and this is a side length. Remember, these across from each other are equal. The bottom line is our base. Base. And all right, side. So we have sides, we have a base, and we know that the sides across from each other are equal. So these smaller sides across are equal. And in a parallelogram, we also have a height, which is from the base going straight up at a 90-degree angle to the top. So this is H for height. Okay. So if I tell you a side length is 4 inches, your base length, let's see, let's say that is 10 inches, and we'll say that our height is sides, let's go with 3 inches. Okay. So I have a side, I have a base, I have a height, and I have a picture. First, we're going to show how we find the area. To find the area of a parallelogram, area can be found by doing the base times the height. So I'm going to write base times height. And the formula that you'll see usually is just A for area equals B for base, H for height. So we've got base times height for area. So using these measurements that I gave you, what would we do to find the area of this parallelogram? Say it again. 10 times 3, exactly. My base is 10, so base height. My area is the base, which is 10, times my height, which is 3. It's super similar, the length times the width. The reason we use base and height on a parallelogram is because one of the biggest mistakes that a lot of students will do is do the base times the side. And that will give you a different answer.
Yeah.
So we want to do the base times the height. So if we have 10 times 3, what will our area be? 30. 10 times 3 is 30. Now since we are in inches, we need to make sure that we write inches. Believe it or not, area is a different unit. It'll be inches squared. Because what we're saying is that inside of this parallelogram, I can fit 30 squares that are an inch each. I can fit 30 square inches inside of this. Kind of crazy. Okay, so we found area. Yes?
When I was first learning about parallelograms, I couldn't wrap my head around how the triangles at the end of the square area were factored in until someone cut one off and then
Yes.
switched it over to the other side.
Let me show that. I'm actually glad you brought that up. So if any of you are thinking, why on earth are we just doing base times height? Isn't that going to leave out the bits where the triangles on the end are? I'm going to show you this, and I'm glad you brought it up. It might help us visualize. So in a parallelogram, I'll just draw another one. We have our base, our height, and of course our sides. And the reason we do base times height is because if I take my parallelogram and I cut it out, let's see, all this is really cool. Okay, my base is at the bottom, there's my height. If I cut off this triangle that's formed by the height, and all I have to do to see why the formula works is I can move it. Ah, look at that. And now you haven't lost any length on your base. This whole thing, this is your base right there. And now your side length is your height. So, just like you would find the area of a rectangle where we would do base times height or length times width, a parallelogram is just a scrambled rectangle. It's the exact same thing, but we use height instead of the side length because this side length, you can tell now, is longer than the height. It would give us the wrong answer. So I think it's kind of cool. Anyway, thanks for bringing that up. Okay, so we've done area. Now, if perimeter is the length around the entire shape, there's also a formula for that. You could just do side plus base plus base. This is also the same length as the base. So if you want, you could write a B there. But perimeter, there's a special formula, and I actually have it on, there's an area and perimeter poster on that wall where all of those formulas will be. They live there. And the formula that they give us for perimeter is to do 2 times the side length plus the base length. Now, personally, I find this formula a little bit unnatural to use. So if you don't ever use this formula, that is okay. You can also do the distributed version where you're doing 2 times the side plus 2 times the base. That's the same. You could also do side plus base plus base. This is the simplest way to do it. This works just as well. So all of these are perimeter formulas and they will all work. This is just like the factored form almost. Back to algebra 2. So basically just add all the sides together. Add all sides together. So if the first 2 formulas here, the 2 times s plus b and the 2s plus 2b, if this is going to confuse you, mix you up, get you, you know, all jumbled, don't even use them. Don't use them. That's fine. It won't bother me any. Do whatever feels better. So how about we find the perimeter now of this parallelogram? How would I find the perimeter of this? Does anybody know?
You add 10 plus 10 plus 4 plus 4.
Yes. Side plus base plus base.
Okay.
My side, or you could do base, side, either one. So you said, I'm going to do it in the order that I wrote it, if that's okay. Side is 4. Another side is 4. A base is 10. And another base is 10. So, let's see. 4 plus 4 is 8. 10 plus 10 is 20. 8 plus 20 is 28. And what would our units be? Inches, not squared, just inches. So, for your area, you multiply base times height. For your perimeter, you just add all the sides together. Okay, that's your lesson today. Just a quick intro. I'll leave this up for a minute if anybody is still copying it down. And I'm going to create an exit ticket. So let me pause this recording, leave this up, and then I will display your exit ticket in like 2 minutes.